Hello everyone, we are the group 4 and the topic that we'll be going to discuss is all about polymers. Now, before moving on to our topic, let me first introduce our group members. Hi, my name is Loris Manlangit and we have Mr. Maron Hari Faustino, Mr. Alam Kenneth, Mr. Argelico Raitos, and Mr. Dave Ian Velasco. Moving on to our topic, I am here to discuss the polymer's origin and its history. Polymer science is relatively a new branch of science. It deals with chemistry, physics, and mechanical properties of macromolecules. Polymers are large molecules of a higher molecular weight, which is called macromolecules, made up of smaller units, which are called monomers. Polymers are made up of repeated linking of small units, which is monomers, joined together forming long chains. The word polymer came from the Greek word poly, which means many, and meros, which means parts of units, or simply as parts. As polymers are formed by repeated linking of monomers, this process is called polymerization. As an example of this is polypropylene, which is a main polymer in plastic, made up of hundreds and thousands of atoms long. These polymers are made up of these monomers, which is called propylene, with the formula of C3H6, which if we add up repeatedly will form a polymer chain. Remember, do not be confused as that plastics are all polymers, but not all polymers are plastics, because plastics is always composed of large molecule, which is polymer. Plastic are synthetic type of polymer and do not occur naturally. As while there are many more of this type, there are also those that are naturally made. Moving on to the two types of polymers, they are categorized based on their monomers and based on their thermal properties. Polymer based on monomers consists of two types, which is homopolymers. A polymer that is built from the same monomer. It is obtained by the polymerization of only one type of monomer. Next is the copolymers. This is when two different types of monomers join in the same polymer chain. As an example of this is polyester. Next is the polymers based on their thermal properties that are also consist of two types. A polymer that soften or melt when heated and harden when cooled. The materials become much more fluid upon heating, allowing them to be transformed in the desired shapes that are stabilized by cooling. Some characteristics of thermoplastics consist of there are no crosslink, recyclable, weak attractive forces broken by warming, weak force reformed by cold. Next is thermosets, a polymer synthetic material that strengthens when during being heated but cannot be successfully remolded. Low molar mass reacts upon heating in the mold to form an insoluble, infusible network. Some characteristics of thermoplastics are extensive cross-linking, bonds prevent chains moving, cannot be reshaped, and non-recyclable. Now, moving forward to our next topic, or should I say, going back from the history, polymers have been an essential component of commodities since the early days of humankind. The use of wool or keratin, paper reed, and cellulose for paper are just few of the examples on how ancient society exploited polymer-containing raw materials to obtain artifacts. The chemical manipulation of polymers dates back from the 19th century. Although at the same time, the nature of this species was not understood. The behavior of polymers was initially rationalized according to the theory of Thomas Gray, which considered them as colloidal aggregates of small units held together by unknown forces. Moving on to the domain of origin, we have Henry Brackenwood 1811. The 19th century development that allowed the nitration of cellulose fibers obtained by cotton linters may constitute the advent of plastics. In 1832, Henry Brackenwood, a chemist at Nancy, one who pioneered the work of cellulose, prepared a cycloiodine by treating starch, sawdust, and cotton with nitric acid. He found out that these materials are soluble in wood vinegar, and attempted to make coatings and shape articles from it. Next is Leo Baekeland, 1907, created the first synthetic polymer, which is bakelite. Bakelite is a good conductor that is used in the manufacturing of non-conducting parts of radio and electric devices, such as sockets, wire insulations, switches, and automobile distribution cups. Hermann Staudinger, 1923, proposed that polymers consisted of long chains of atoms held by covalent bonds. In 1920, Henry Staudinger published his seminal book, which is titled Über Polymerization, in which he proposed that polymers were in fact long chains of atoms linked by covalent bonds. His work was debated by length, but eventually it was accepted by the scientific community. Because of this work, Staudinger was awarded the Nobel Prize in the 1953. Last is Paul Froude. He is the one that did an extensive work on addition polymerization, chain transfers, and excluded volumes. Moving on to the classification of polymers, let's first define the polymers based on source. There are three types of classification of polymers based on source. First is natural polymers. The polymers that are naturally occurring. They are the results from raw materials that are found in the nature. Some of these natural polymers includes DNA, which is classified as polymers as it consists of numerous nucleotides units, which is there are four. And DNA is termed as polynucleotides because of the repeating phosphate sugar backbone structure of the molecules. Other examples are RHA, wool, cellulose, protein, starch, silk, and rubber. The next type is synthetic polymers, as sometimes referred to as plastics. These are polymers that are man-made, produced by chemical reactions. They are synthesized from low molecular weight compound. Example of this type is nylon. Because it is made from polymers via a chemical process, it is considered to be a synthetic material. Lastly is semi-synthetic polymers, are those that are derived from the nature but made to undergo chemical processes to enhance their quality, derived from naturally occurring polymers by chemical modifications. Example for these are rayon, also known as cellulose acetate, is a semi-synthetic polymer that has a superior properties to natural cotton fibers. Other examples are vulcanized rubber and gun cotton.
Classification based on structure were consisted by four types of structure that we see in various types of polymer. These are linear polymer, branch polymer, cross-link polymer, and lastly, network polymer. So let's start in discussing linear polymers. Linear polymers consist of long chain-like structure where repeating units are joined together end-to-end. The long linear chain are flexible, where van der Waals and hydrogen bonding may occur between polymer chain, while closed approximately, leading to chain entanglement. Linear polymer is a long continuous chain of carbon-carbon bond with the remaining two valence bond connected largely to hydrogen or another minor hydrocarbon component. It is the most basic polymer and consists of a single straight line of carbon-carbon bonds. It can form strand of fiber or mesh that is exceedingly hard and difficult to break. Yet, on the contrary, various types of linear polymer has a thermoplastic characteristic, making them vulnerable and easily to break against the heat. To add to, it destroys the bond between a long chain, reform. Moreover, the polymer hardens. The third one is the polyamide, also known as nylon, a high-performance property in the polymer families. It has a high mechanical strength, modulus, chemical resistance, and thermal stability. Because of this durability, it is frequently used as a material to create heavy-duty fishing nets. Here are some of examples of linear polymer. First is polyethylene, most commonly known as polyethylene, a light thermoplastic material made from ethylene with properties depending on the molecular weight of the polymer. It is the most commonly produced plastic that was being used mainly for packaging, such as plastic bag, plastic film, as well as the bottle that help us a lot in our daily basis. Polystyrene, a polymer made from the monomer styrene, a liquid hydrocarbon that is commercially manufactured from petroleum. It is normally a solid thermoplastic but can be melted at higher temperature for molding or extrusion. then resolidify. One of the example of it is the expanded polystyrene foam, or much known as styrofoam, that was being used not only in single-usage utensil but also in packaging to secure electronic materials such as refrigerator. The branch polymer were a result from side reactions during the process of polymerization, making the main backbone spread. For this reason, the structure of branch has a huge resemblance to the linear polymer structure. To add to, this is also the reason why branch polymer density is much more lesser than the linear, making it much more vulnerable in heat. Heat will typically break the bond between the branch polymer chain and allow the polymer to be thermoplastic, since the short chain do not bridge from one longer backbone to another. Yet, there are still few that can resist to melting, that result to becoming hard in the process before it softens. The branch or side chain are composed of the same repeating unit as the main polymer chain. Branching is probably supported by monomer that have two or more end groups. Furthermore, it should be comprised by a minimum of one complete unit for it to be considered as a branch polymer. Example of branch polymer: low-density polyethylene. It has a wide application ranging mostly from plastic bags, textile container, to coating various packaging materials such as newspaper, coating for cold and hot beverage, as well as plastic storage containers. So let's proceed on cross-linked polymer. The linear polymer chain or cross-linked polymer are joined together via covalent bonding of smaller molecules acting as a bridge between them. The cross-linking process often takes place through a non-reversible chemical reaction process, or much known as curing. Cross-link formation characterize thermoset polymers. The three-dimensional network of bond, or known as cross-link polymer structure, is more likely a ladder-like structure that connects one backbone into another. Crosslink is being tied up by covalent bonding, which is stronger than the linear polymer, which are being held by a weaker bond-hole bond. This much more stronger bond make most of the type of crosslink the thermosetting. To add, it makes the thermosetting stronger to thermoplastic material, yet crosslink polymer that happen to break their crosslink are relatively low temperature. So one of the example here is polyurethanes, that are being used as a coating adhesive, vulcanizing rubber, epoxy resin, polyester glass, and many other more. So now let's proceed on network polymer. Network polymer feature mere unit with three active covalent bonds and have the ability to form interconnected three-dimensional network configuration. Network polymer includes highly cross-linked polymer. For example, highly cross-linked epoxies are often described to have a highly cross-linked three-dimensional epoxy network configuration. Network polymer are extensive polymer that have been strongly connected to produce a complex network of three-dimensional connection. These polymers are thermosetting polymer because they are practically difficult to soften when heated without destroying the underlying polymer structure. It creates massive, intricate chemical bond structural that cannot melt without going through process of decomposition. Moreover, network polymer do not easily dissolve, while they may weaken and swell when exposed to solvent. Most network polymers are therefore inappropriate for forming into fibers due to this characteristic. Example here is the vulcanized synthetic rubber used in automobile tires. Generally, polymerization is defined as a process in which two or more monomers is engaged in a chemical reaction and form long polymer chain or three-dimensional network. Polymerization usually occurs by a different reaction mechanism which are affected by factors like the functional group of the reaction compound and their non-bonding interaction. In any case, there are mainly two types of polymerization, which are addition polymerization and the condensation polymerization. Molecules of the same or different monomer combine on a large scale during addition polymerization to generate polymer. Alkynes, alkadines, and their corresponding derivatives are unsaturated chemicals that make up these monomers. Example of it is Teflon, polyvinyl chloride, polyethylene, and etc. Condensation polymerization is a form of step growth polymerization where smaller molecule or monomer react with each other to form larger structural unit while releasing byproducts such as water or methanol molecule. The byproducts are normally referred to as condensate. In condensation polymerization, the condensation process between two bi- or trifunctional monomeric units is repeated. Examples are perylene, polyester, nylon -6, and nylon +6, etc.
Characteristic of polymers: low density, low coefficient of friction, good corrosion resistance, good moldability, excellent surface finish can be obtained, economical, poor tensile strength, low mechanical properties, poor temperature resistance, and moreover, can be produced transparent or in different color. To further define the characteristic of polymers, let's divide each one into the advantages and disadvantages.
This is the advantages of polymers in production. The means of making polymers is very simple and accessible. It only requires one process plastic injection to render the shape. Acquiring the materials is even easier as their byproducts of petroleum, which costs little to nothing. And their properties and their some advantages of polymers. Polymers are known to be almost neutral in conductivity, so they cannot hold an electrical charge, nor can they conduct an electrical signal. Because they have such low conductivity, they're relatively safe to work with. Polymers are also resistant to most elements, making them non-corrosive, and they don't biodegrade. This makes for a long-lasting products upon which we can rely for industrial needs. Now, I discuss the advantages of polymers. This is the 9 advantages of polymers. First of all, the low density. Polymers have a low density. They can be used in electrical insulation. Second is the low absolute strength. Because at lower molecular weight, the polymer chain are loosely bonded by weak van der Waals force, and the chain can move easily. The third is stiffness, or some call rigidity. Is a property of a polymer that is described by flexural modulus of bending modulus of elasticity. Fourth is ultra durable. It's because the durability of polymeric materials is intended as the average life in service condition depends on several parameters. The most important being the chemical nature and composition of the polymer, the process used to manufacture and or to apply it. Fifth is resistance to corrosion. Polymeric materials are not corrosion proof. Preventing failure involves grasping the complexities of corrosion in these materials, and polymeric materials have wide application. Therefore, there are many factors that can lead to corrosion in these materials. Next is thermal electrical insulator. Polymer are thermally insulating polymers, and resins are compounds that are engineered to minimize or reduce the heat transfer between objects and in thermal contact or in a range of rigidity radiative influence. Next is flexible. The cause of flexibility of polymeric chain is the existence of a certain freedom of rotation around the valency bonds of the atoms making up the molecules. Next is cheaper. Their low cost has its roots in the abundance of the feedstocks, in the ingenuity of chemical engineers who devised the process of manufacture, and in the economies of scale that have come with increased usage. And the lastly is recyclable. Recycling of polymers can be defined as activities able to recover matter or energy from post-consumer plastics. There are different options can be selected in polymer recycling, from mechanical recycling to chemical recycling and energy recovery. This is the 9 advantages of polymers. Now, remember, products made from polymers are all around us. Clothing made from synthetic fibers, polyethylene cups, fiberglass nylon bearings, plastic bags, polymer-based paints, epoxy glue, polyurethane foam, cushion, silicone heart valves, and Teflon-coated cookware. The list is almost endless.
After defining the average of polymers, we must also understand the disadvantage do not apply to every polymer. This makes some of disadvantage of polymer be its disadvantage also. As an example, this is plastic. It may be useful for your daily living but not good for your environment. Going to disadvantage of polymers, here are the main ones of the most be remembered. Hello guys, my name is Aljerico Oraitos. My topic is disadvantage of polymers. First disadvantage of polymers. Low density. The low density of polymers is a disadvantage because it means that they are not strong or durable as other materials. This limits their use in application where high strength is required. Additionally, low-density polymers may be more susceptible to damage for environmental factors like temperature changes, UV radiation, and mechanical exposure. The second disadvantage of polymers, non-biodegradable. The non-biodegradable nature of most polymers is a significant disadvantage because it means that they do not break down naturally in the environment. This can lead to long-term accumulation of plastic waste, which have negative impact of wildlife, ecosystem, and human health. Additionally, the product of non-biodegradable polymers requires significant amount of energy and resource. Third disadvantage of polymers, easily breakable. Some polymers are brittle and easily breakable, which limit their use in certain applications. For example, brittle polymers may not be suitable for application where high impact resistance is required. Additionally, the brittleness of polymers may limit their ability to be recycled, as it can make it difficult to process and reuse them. Fourth disadvantage of polymers, flame retentancy is low. Polymers have low resistance for flames, which means they can easily catch fire and burn. This is a disadvantage of application where fire safety is a concern. In order to improve flame retenancy, polymers may be treated with additives of costing which can add to their cost and complexity. Fifth disadvantage of polymers: poisonous gases. When polymers contain additives or breathed, they can release toxic gases into atmosphere. These gases can be harmful to human health and environment and contribute to air pollution. The release of toxic gases during polymers combustion is a significant disadvantage, particularly given the widespread use of polymers in customer products. Sixth disadvantage of polymers: difficulty in recycling. Low molecular weight polymers like polyethylene bags are difficulty to recycle because they are lightweight and do not easily break down. This means that they can accumulate in landfills as litter, causing environment pollution. While efforts are being made to improve recycling technology for this type of polymers, they still present a significant changes for waste management. 7 disadvantage of polymers: environmental pollution. Improper disposal of polymers can lead to environmental pollution. This can include littering, which can be harmful to wildlife and ecosystem, as well as soil and water pollution for landfill waste. The environmental impact of improper polymer disposal are significant concern, particularly given the widespread use of polymers in customer products. That is all. 7 types of disadvantage of polymers.
Uses and applications of polymers. Polymers already have a far more applications than any other class of materials available to men. Adhesives, coatings, foams, and packaging materials are among the current applications. There are textile and industrial fibers, composites, electronic devices, and biomedical devices. For many newly developed high-tech ceramics, polymers are important structural materials and contribute to many important biological processes in an organic sense. Polymers are ubiquitous, particularly synthetic polymers. Polymers are likely to be used wherever there is a need for low-cost corrosion resistant, low-density, thermal, or electrically insulating materials. Understanding how a material behaves over time allows us to assess its potential application and use when considering a polymer application. It can provide polymer failure analysis and identify design flaws or molding problems. Number 1. Medicine. Polymers has a wide range of uses and applications. It has many advantages because of the physical, chemical, and biological properties, which can match the specific requirement for their uses. Polymers are so versatile in its structures, properties, and constitution that many fields use polymers as an application or material. It is used in biophysics, medicine, electronics, and other branches of technology and science. Among the other polymers, biomedical polymers are always mentioned due to their long shelf life. Lightweight, less toxicity, remarkable properties, and easy to process. Many reports in the medical field that there is significant improvement in specific polymer composite biomaterials that shows great results and can be a help in biomedical that includes bone healing, tissue engineering, imaging, cancer detection, and treatment. There are many types of polymers that are used in the medical field, like polyl-lactide, biological polymers, hyaluronic acid, low molecular weight, HA, a polymer that has been reported to show anti-inflammatory effects, fast-wound repair response. Number 2. Consumer science. As portrayed, polymers have a wide range of uses in various fields, and one of them is consumer science. Polymers are used in almost everything and can be found in almost every material used in our daily life. The importance of polymers has been highlighted because of their applications and uses in different aspects of industry, science, and technology. And from the basic use of polymers in the industry and science that will impact the daily lives of humans. In the industrial, polymers are used in plastic containers, clothing, floor coverings, packaging, garbage bag, cosmetics, hygiene products, beverages, and many more. Polymers are used in consumer science because of the reason that polymers are less expensive than traditional materials or old materials used for packaging. It is not surprising that polymers are used for packaging and daily life uses. Number 3. Industry. Polymers in the industry are vast and diverse and are used in many fields. The versatility and wide range of maneuverability because of its characteristics that makes polymers one of the most used materials in manufacturing items in all shapes and sizes. Some polymers that are used in the industry are suitable for extreme weather, and some are water resistant, flame retardant, and capable of operating at extreme temperatures. No matter what application, these polymers are used for the job. Polymer materials in the industry are usually used in creating automobile parts, pipes, tanks, packing, materials, adhesives, and many more. Number 4. Sports. In the sports division, polymers are used in the wide range of sports and has a great impact and are most likely to be used in gear or clothing, and instrument or tool used in games. The utilization of polymers in the sports division is essential and it is for players to be comfortable and safe. With the creativity of the manufacturer, the use of polymers as a material to put into great and high quality tools and equipment that can be used for a long time. Some sports have been considered to be dangerous and some can lead to injuries. Polymers are used in sports equipment to lessen injuries and the impacts. And most importantly, it is comfortable, lightweight, high-strength, durable, and water-resistant material that enhances and supports the performance of athletes.
To conclude to our lesson, polymers are widely used advanced materials which are found almost in every material used in our daily life.
Today, the importance of polymers has been much more highlighted because of their applications in different dominions of sciences, technologies, and industry, from basic uses to biopolymers and therapeutic polymers.
The rapid increase in demand for the manufactured product introduces the new materials. These new materials are polymers and their impact on the present way of life is almost incalculable.
Now, remember, products made from polymers are all around us. Clothing made from synthetic fibers, polyethylene cups, fiberglass nylon bearings, plastic bags, polymer-based paints, epoxy glue, polyurethane foam, cushion, silicone heart bulbs, and Teflon-coated cookware. The list is almost endless.
As Lord Todd summarized in 1980, I am inclined to think that the development of polymerization is perhaps the biggest thing that chemistry has done, where it has had the biggest effect on everyday life. That concludes our topic. Thank you for listening.